Now, since we have understand that, let us now convert our PIL image, pillow image, to NumPy array, right? So for that, I'll say transformations. And in fact, I'll say transforms to tensor. Yep. So I'll say transforms dot compose. Now, what this compose is, it is actually going to create a series of image transformation. Out of those transformation, one of it is to convert into tensor. You take this transforms and pass in to tensor, right? So it transforms PIL image to a torch tensors and scale the values between 0 to 1. Yeah. And this I'm going to assign to transform. So I'm assigning this instance to transform here. Just transform, not S. Okay. Now, if you take this transform here and use the same cell that you're taking this transform and passing in that image cat, which you can assign to IM, for example, image. Now we take the IM, for example, and we print IM.shape. It is going to print the tensor shape, that is this. Oh, it has given an error. Let me check what is going on. Yeah, this is transform again, spelling mistake and all that. Transforms. I hope it is fine. Oh, I see. The point is you have to put a list here, right? And I'll tell you why we are putting this as a list. But for now, you have to put that as a list here. Now, if you see the resultant here, we are getting three values. Now, what is this? This is color channel and then image height and then image width, right? So basically all the images you can see here, it is a tensor, right? You can see it's a tensor here. Yeah. So all of them, they are basically combination of color channel, height and width, all the images. And I'm just talking about this one image here. That image is having all this value in this tensor, right? Now, this is the same image that is converted to tensor and displayed using this. Now, how we are getting this? For example, I told you that the first value that we had gotten for 0, 0, let me put this back to 0, 0 here. If you take this 0, 0, this is 14, 31, and 100. Now we take this 14 divided by the maximum value, this 255, and then we have 31 divided by 255, and then 100 divided by 255. So if you run that, I'll get three values, which are this. Now see, is this confirming to this? 0459. Then you have 12156. And lastly, you also have 0.39. Well, this might not be clear. What I'm going to do is I'm going to take this tensor that is IM, and I'm saying get me all the color channels and pixel 0, 0, right? And you can see here this is going to give me the topmost on the left side pixel, right? So 0.0549 and 0.12. So this is going to give you the, similarly, we have done this for all the pixels here. Again, this is a three-dimensional image. Since we have color channels and height and width, thereby I'm getting this kind of a very complex thing here, but it's the same idea. Okay. I just said that there are a bunch of transformation that we can apply. And I've just applied one transformation, that is we are taking that image and converting them to the tensor. What we are going to do now? Well, what you can also do is you can take this, for example. Yeah. And just one more thing before I, proceed further. What you can also do is you'd want to display this image. Now, once you have this in in tensor, you cannot just display it like that. You just pass in IM. Maybe I'll get if I just pass this IM, I'm going to get the tensor here. So to display this, I will use Matplotlib library. Now, there are certain things that you have to understand about Matplotlib library. First of it is that Matplotlib library, it only works with NumPy array. That is, you will take this tensor and convert this. Again, this just to display the result, and serves no other purpose. So to display this using Matplotlib, I'm going to first convert this into NumPy array by saying dot NumPy. And if you run that, I'll get this. This is good. You're getting this in NumPy array. You can see this. But the problem here is that this actually uh, poses some other problem. The problem is that we have to convert, or should I say, reorder the axis to height, width, and color channel. Okay. For plotting with Matplotlib, again, it serves no other purpose. We have to reorder the axis. So first axis in tensor, which happened to be color channel, that is not the case. It is height now. So basically, I want to say that, okay, this is again height. So basically, I want to say that you are going to put np dot transpose and take this particular array and pass in. First would be the height, then width, and the color channels. Because color channel was the one that came earlier, if you remember, right? This was the color channel in that three-dimensional image. Um, and then we had the height and width. So I'm basically, putting that color channel at the very last, and I'm going to take this and then plot this out. Again, this is kind of, complex to understand. I know that, but the point is we are again using this to just display the image. This, it serves no other purpose really, right? So why we have done that and not just used this kind of, you'll see that shortly, but basically you have this thing here. Okay. Again, why we had to reorder? Because that is the way my Matplotlib accepts it. Okay. And I'll put this kind of a note here as well, because it is an important part that you'll have PyTorch format is color channel, height, and width. And the next one is Matplotlib. It expects you to pass in height, width, and color channels. That is the point here, right? So when I'm using Matplotlib, I have to kind of, swap them around, put this color channel to last, height to here, and width to at the second number. So height becomes this, then two, sorry, this becomes one, then two, and then zero. That is exactly what we have done here, right? Now, with this in mind, let us look at some other transformation, that is resize. Again, so basically, you have to understand that in resize, uh, what we are doing here is we are going to put all the different sizes of image. That is, you're going to take the size of this image, for example, is 375 by 500. Similarly, if you take some other image, maybe this one, you'll get some other size, right? So I want to take the sizes of all the image and put them in the same sizes. Okay, so I'll say that This again is 3, for example, and transforms here. And I'll say that I'll copy this entire thing, come back, and just add one more argument. I'll say transforms dot resize to 224. Again, we are resizing the smaller edge to 224 pixels while keeping the aspect ratio intact, right? So if you put 224, that's only going to resize the smaller dimension. So if I run that, for example, I'll get 224 here, okay, while maintaining the aspect ratio. But if you want to put that in 224 by 224, for example, you'll pass it as 224 here, right? Now, why we have chosen 224, by the way, uh, that is because of the reason, well, first of all, just to be clear, when you're getting this error, that is because of the fact that you have to pass it in a tuple. So pass in tuple, and you'll see that you're getting 224 by 224 now. Okay. Anyhow, the point is why you'd want to put 224 specifically, because right now we are creating our own models, but it is a no-brainer to think that there are some pre-existing architecture as well, pre-trained model as well, and that accepts data in a certain format. That certain format is 224 here, right? That is exactly why we have to use 224. All right. Now, uh, so I'll say this, and you know, so this was about resizing the image. Now let us talk about um, center crop. What is a center crop? Basically, right? What it does is it takes for example, a square of certain size, and it is going to just perform some center crop here. The best way to understand this is just to use it. So I'm going to do that. I'll say take this and just remove this part and put center crop. You'll say transforms dot center crop and put some size, for example, 224. If you run that, I'll get this image. You see, I've really cropped my image at the center, right? So this crops the original image here. Yeah. Now, just to be clear, if you want to be, it might be better actually to first do the resize and then perform the center crop. So, for example, for that, you'll say transforms dot resize and pass in 224 by 224, right? And here, if you run this center crop as it is, by the way, if you run this as it is, you're going to get the same image. But if you pass in center crop with, let us say, how about 124? And if you run that, you'll get kind of this center crop here. Okay, you have cropped in that image. Again, see the toe size, 124 by 124. All right, very important and very useful. Great. Now, what you can also do is perform some other affine transformation as well. And one of which is very important is the random flip. This is like the default transformation always. All right, so you'll say transforms dot horizontal flip. And what I'm doing here basically is you'll say transform equal to, um, in fact, I'll just do a copy paste. And here you will see that instead of resize, I'll get random horizontal flip. Yeah. And if you check this, it has this argument called as P. Now the default value of p is 0.5, but what this p is, it is the argument that tells you that, what is the probability that the image will be flipped. The default value is 0.5. So 50% of time the image will get flipped. There are 50% chance that image will get flipped. But I don't want this to be 50%. I want this to be 100%. So I'll put p equal to 1. And if you run that, you will kind of, flip the image. Yeah. And again, if you just play around with this value, maybe I'll put 0.2, 20% chance. Now, if you run this, most of the times it's not going to get flipped. Well, it has, flipped this, but most of the times it's not going to get flipped. And rest of the times it might get flipped as well. So this is just nothing but a probability value. You can feel free to put that value if you don't, if you want to, but I would say just 0.5 is a perfect number. So you don't have to, change that. But just to explain this, you'd have to put a p equal to 1 to see the effect that it is actually working uh, just fine. This is horizontal flip. And then brings me to transforms dot random rotation. And what this does is you are going to rotate your image with certain degree. So I'll say transforms dot random rotation. And you can pass in bunch of things here. For example, you'll if I say 30, you'll just rotate randomly between -30 to +30. If you run that, you will see that you see this black color here. So we have rotated this by a bit. But if you just run this, you can see again, every time you run this, you are going to rotate it with some degree between -30 to +30. Now, if you want to set some range here, you can do that as well. And for that, you'll pass it a tuple between, for example, 1, 2, 3, 59. Yeah. And that is going to take any degree between 1, 2, 3, 59 as well. Again, just to be clear, when you're passing the range, you cannot enter a negative number, but you can put any number from 1 to 360. But again, 360 is the maximum degree that you can rotate it through. So this is what you can do as well. This is the job of rotation. Yeah. Well, so we have done all the transformation that, sorry, we have seen all the transformation that we needed to. Now what you have to do is just see how to put them together. Yeah. So I'll say transforms, or should I say, I'll just do a copy paste here and I'll just insert some number. For example, I'll say, sorry, I'll insert some arguments. I'll say transforms dot random rotation and just put some number. Maybe I'll put a number of 30. Again, you have to be realistic because, for example, if you have taken an image of the cat, you can at most, if you use your hand, you can rotate it by at max like 30 degree. You cannot remove your, because your hand will not work, right? So in real life images, most of the times the image that you're going to get is going to be a rotation of between 30 to -30. But again, it is your choice. If you want to keep your model kind of a well performing throughout, and if you want to make it as robust as possible, you'd want to put that any rotation from 1 to 360. But in real life, you're not going to rotate it beyond +30 or -30. So that is why we have put that as 30 here. And then we also have the center crop. So basically what you have to do is just put those argument and put just put a comma here, and that would be it. So transforms dot resize. Oh, resize we have already done. What about that? Then we have random horizontal flip, and I'll put p equal to 0.5 only. And then one more, I'll put center crop. Yeah. And that's going to be 224. If you run that, you have to put a comma here. If you run that, you will get this image, right? Again, every time you run this, there will be kind of, since there's a random value here, you're going to get a different image here. Okay, now once this image has been loaded into a tensor, we can now perform a normalization to this. What is a normalization? Yeah. So if you check this image that we have gotten, which is IM, if you check this, this is this value. Well, never mind. All right. So the point is, we can perform a normalization on this image here, right? So this serves to make convergence happen quicker during training. The values are somewhat arbitrary, and you can use a mean of 0.5 and standard deviation of 0.5 to convert a range of 0 to 1 to -1 to 1, for example. However, the research have shown, again, this has been empirically found, that the mean value to perform normalization is this 0.485, comma 0.456.406. Yeah. And the standard deviation, again, empirically found, I have nothing to do with it, 0.229, 0.224, and 0.225. Yeah. Now, if you take this and perform some normalization based on this value, how you're going to do that is this. So I'll say, just copy paste one more time and say that, it is not resize that I want to do. I'll just want to perform transforms dot normalize. And if you see, if you do a quick shift tab here, you can see it is expecting me the mean value and the standard deviation value. So I'll just quickly do a copy paste here. So the first argument is the mean, thereby this list, and second argument is the standard deviation. All right, and if you run that, you will get this image. Now you might think that you're getting a wrong image here, but that is not the case here, right? After normalization, when you normalize this, the value go beyond 0 to 1, and thereby image will look distorted in matplotlib. That's normal, but if you want to visualize this properly, you will need to denormalize this, right? And again, this is just again for normalization, but the before I show you that, I just showed you this first pixel here somewhere. Yeah, there you go. So this was the first pixel of our image. Now if I run this one more time after normalization, you will see the same value is now this. Yeah, point 1768 and all that, right? Because of this dark color here. So when displayed, this matplotlib clipped this particular value to 000, so it appears black on the screen. However, appearance is not important. The goal of the normalization is to have the improved performance by manipulating the tensor. Anyhow, if you want to see the original image, for example, if you have seen this kind of normalized image, what you have to do is you have to denormalize the image. Again, purpose of denormalization is nothing but to display the image. So you will see that again for denormalization, you will, just like how you have done the mean and standard deviation, you would also perform the inverse of that. That is inverse normalization, and those value is transforms dot normalize, and here you will pass in mean equal to minus 0.485 divided by 0.229 divided by minus 0.456 divided by 0.224, then minus 0.406. Again, this values, it has nothing to do with me. It has been empirically found, and I'll just, do, you can do a quick Google search on this as well to just check whether it is being empirically found or not, right? And you'll say standard deviation is 1 divided by 0.229, I think. And again, these are the value that you should kind of, if you have enough practice, you can just, you'll just remember this in one go, right? You can buy hard this basically. And once you have this, I'll take this inverse normalization and pass in your image in this and assign this to image inverse here. And then I'll just kind of, you know, see this, the figure, making some changes. So this is image inverse now. Yeah. And rest of it is fine. So let us run this. There we go. So again, we are displaying the same image as before after doing the denormalization. Again, if you ever encounter this kind of image, just know it is that. And if you're using this, matplotlib, obviously, in that case, just know that is a normalized image. To denormalize this is what you can perform. Although in real life, that's very going to be rarely the case that you'll be, kind of, seeing the image in mid process of a building this neural network. But this is kind of very useful as well. Well, anyway, in this particular video, we have seen how to convert the images to tensor. We understood how pixel normalization work. We saw, how to fix display issues with transpose. We did some transformation, resizing, cropping, and we did some documentation as well, flip, rotation, and all that stuff, and some normalization practice as well. And this is really, in my opinion, the backbone of any image pipeline in deep learning. Next up, in the next video, we'll start creating convolutional neural network and start doing actual image classification. With that, it's a wrap for now. I'll see you in the next video.